Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the concept related to electric vehicles and hybrid electric vehicles. Along with that, we are looking into the components which are responsible for building off this entire vehicle. In this particular tutorial, we will have a look into the buck converter with the implementation, covering also the desired parameters to obtain the required voltage level. And along with that, in the previous tutorial we have seen the conceptual understanding of buck and boost converter. In case you are interested, please have a look into the same. So let's get started with the buck converter implementation in this video. So as we want to design a buck converter, so basically what we want to design is whatever the input voltage that we are receiving in the input, we just want to lower it down so that we can charge a lower voltage battery. As you can see in this case, we have a 60-volt battery, which is a high voltage battery. Along with that, we also have a 12-volt battery, and we want to charge the 12-volt battery with the help of this 60-volt battery. So when we convert this power from 60 volt to 12 volt, definitely we will get some ripples. So let's design the different parameters which involves the values for the inductor, capacitor, and the load resistance, through which we will be able to do the implementation for the requirement that we have for now. So coming to the design aspect of the buck converter, we do have four parameters. One of them is the duty cycle. This decides how much time the switch should be on or off, and that way we can control the voltage. Next parameter is the inductance, and this is basically deciding how much current ripple is allowed in the circuit. And the next parameter is the voltage ripple parameter. So this decides, like in the output voltage, how much ripple is allowed in the output. Based on that, we will be designing, and based on these current and voltage ripples, right, we do also have to design the capacitor, and that will have its own capacitance. So that is how the buck converter is designed based on these four parameters. Coming to the duty cycle D, we do have this as a ratio of V out by V in, and here we are having the voltage of 12 volt as the input and the 60 volt as the output. So based on that calculation, we are getting the calculation of a duty cycle for 20%, which is basically 0.2, and the same is represented with the help of this graph that you are able to see. So it will be on for 20% of the time, and it will be off for the 80% of the time. That way we will be able to achieve the output voltage of 12 volt based on a 60 volt input. Then coming to the implementation related to the inductance. So we do have the equation based on this, and based on the calculation and the frequency that we have used, we are getting a 192 microhenry of the inductance. So through that, we are basically considering a ripple of current, basically delta IL of 0.5 amps. So this is the allowed ripple from the inductance side, and based on that, we basically have L as 192 microhenry as the design parameter. So this value we will be using in our design. Next is the coming calculation for the voltage ripple. So this is the formula, and based on this we do have calculation, and the output is, which is basically 0.012 volt, and based on that, what we are able to assume over here is the whatever the voltage that it will vary within this range, the maximum and the minimum variation, that is the delta V out. So this is the voltage ripple that we are doing the calculation for. Next is the capacitance calculation, and this is the formula for doing the capacitance calculation. And this will be the output capacitance, and based on this formula we do have calculation of 5.2 microfarad as the capacitance that we will be using. And this will be considering both the current ripple and the voltage ripple that we are having. And based on this, we are having a 5.2 microfarad capacitance. So till now we have covered the determination and the calculation for individual parameters related to the buck converter circuit. In the previous tutorial, we already seen like how the circuit looks like, but here we are just assigning different parameters which we will be using to convert 60 volt to 12 volt. So our source is 60 volt and our output is 12 volt, and based on that we do need to determine those parameters. So first parameter is for inductance, that is 192 microhenry, and the capacitance will be 5.2 microfarad. Along with that, we do need to consider the duty cycle also. So for the calculation which we seen already is the duty cycle is 20% or zero point 0.2. So with this, if you jump to the MATLAB implementation, so it will be like you need to consider the parameters. So here we do consider all the parameters. This is the inductance, the value that we considered. Resistance we take as a example because this is not a circuit component that we will be using, but it will be used to measure the voltage across the load. So we are considering here the resistor as their load. Now the capacitance value is 5.2 microfarad, which we assigned it over here in the C variable, and D is the duty cycle. This is 20%, and we do have input voltage of 60 volt, and with this we should get at least 12 volt with some ripples. And this is the frequency at which the switching will happen. So this is 1000 kilohertz. So all these parameters we do consider while designing this converter. Now coming to the simulation, we do define all these parameters. Now we need to open the model that we already have, and then we need to simulate it. So let's see how the model looks like. So this is the model. We can see the components are being arranged. This is the 60 volt voltage source, which you can see. So we assign all these values from the MATLAB main workspace with the help of the script that we used. So based on this, it is the same circuit diagram. You can check. And now suppose if you want to simulate the model, if you see the script, then we will just run this one. So first we will, because there are some multiple calculations that I want to show you later on in further videos. So if you want to see the basic behavior in the, so we need to select this. So we will have to evaluate. So we got all these parameters. Now we will be running our model, evaluate. So it will run the model. Now if we want to see, so this is the basic behavior. As you can see, initially the capacitors is building up the voltage, so you can see like more positive current is flowing in the inductor, and that is helping to build up the voltage in the capacitor. And along with that, as the voltage settles down, you can see the charging area is getting reduced, and it is achieving an equilibrium. Once it achieves an equilibrium, you will be able to see a stable voltage across the capacitor output. So you can see a stable voltage across the capacitor output. If we zoom out more, some more stability you will be able to see. And that is how a buck converter usually works.
This is the implementation, but if you see, we do have two modes in the buck converter. One is continuous conduction mode and another is discontinuous conduction mode. So we will have a look into the same in the coming video, so that you will get a better insight into these two operations of the buck converter. Basically, it depends on the amount of load that we use. And yeah, so in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to help you with your doubts and query. Have a great day ahead. Happy learning MATLAB. Thank you.